Hi again. Today we're going to continue talking about functions and function operations, and this video is dedicated to one function operation, which is the composition of functions. So at the end of this, you should be able to compose functions. Okay, the two functions we're going to look at, f of x and g of x, should be very familiar from the last video. We're going to continue to work with those and figure out what composing functions really means. Okay, so some notation. You're going to take a look at this here. What does that say? It looks kind of ugly. How you would say this is f of g of 3. So what this means is ignore f for a second, right? You just have g of 3, which means you take 3 and plug it into g. Okay, now f is on the outside, so we're going to work inside out. So this still says you're going to take 3 and plug it into g, but then f being on the outside says whatever you get from that, you're going to plug into f. Or really, what the input of f is you're going to plug whatever g of 3 is into f, right? Because f's parentheses are here, and g of 3 is inside them. So the input into f is g of 3. So I really like this arrow thing. It gives a nice illustration. 3 goes into g. Whatever you get there goes into f. This would be easiest with an example, so let's try this. So first I'm going to find g of 3. Okay, g of 3 means plug 3 into g. And g is still x squared plus 1, so it's really 3 squared plus 1. If I simplify that, it gives me 10. Okay, so g of 3 is going to give me 10. And I'm going to take that now and I'm going to plug it into f. Okay, so I'm going to replace g of 3 with 10. And really this says f of 10 because 10 is g of 3. So now I'm going to take 10 and plug it into f. So that'll just be 2 times 10 plus 5. Which is 25. And so I took 3, plugged it into g, and my result I plugged into f. Arrow, arrow. Okay, I always like to think about this as like putting continuous rules on an input. So like something we talk about a lot with this is sales. So if I get a 10% discount and $5 off, does it matter which order I do those in? This is actually going to answer that question, so maybe ponder that for a later conversation. Now, if we don't have a number and we just have g of f of x, it's going to work the same exact way, but people get confused because they're variables, right? So what this says is you take x and plug it into f, which x is already plugged into f, so you don't really have to do anything there. And then you're going to take f of x and plug it into g. So really what this says is you're taking g of f of x, which is g of 2x plus 5. I substituted 2x plus 5 in for f of x. Okay, so now I'm going to take 2x plus 5 and plug it into g. So 2x plus 5 is going wherever you saw x's before. So now it's going to be 2x plus 5 squared plus 1. Now 2x plus 5 squared means I multiply 2x plus 5 2 times. An exponent is repeated multiplication. So this is 2x plus 5 times 2x plus 5, and then we'll do the plus 1. So I'm going to double distribute this. So 2x times 2x gives me 4x squared. 2x times 5 gives me 10x. And I'm going to distribute the 5 as well. So 5 times 2x is again 10x. 5 times 5 gives me 25. And then we have the plus 1 on the outside. So we always do multiplication before addition or subtraction if you follow PEMDAS. So I'm running out of room, but that simplifies to 4x squared plus 20x plus 26. Okay, so if you have g of f of x, you should end with a function. If you're plugging in numbers, you should end with a number. Okay, so again, you're just doing multiple inputs. So x goes into f goes into g. 3 goes into g goes into f. Now, you might see some alternative notation, which looks like what you see below here. So it's like fog of x, right? This should hopefully remind you of the last video. This essentially means the same thing as what you saw above. So it means, well, actually, let's start with this little O thing. It's not an O. This is the notation for function composition, which is what we did above. It's not an O, right? Okay, and what this really says is f of g of x. Okay, these notations mean the exact same thing. So whenever you see this, you might want to write this down. Whereas this one says g of f of 2. So this tells you what the first input is, goes here, and then f of 2 gets plugged into g. So again, you can always rewrite them that way. So I'm actually going to leave these for you to try on your own. So I'm going to pause the video and do both of them. and I expect you to pause and try these on your own to practice. I'll come back with the answer so you can self-assess. Okay, I've completed both problems. Check your work with mine. If you've done 3 correctly, you should get 2x squared plus 7, and 4, you should get 82. So see what you understood, see what questions you have. I'll kind of talk through some of it, but if you have further questions, please let me know at some point. Okay, for this one, you should take x and plug it into g, but that's already done because g is x squared plus 1. So really what this says is you'll take g of x and input that into f. So I rewrote that here. It says my input into f is g, which is x squared plus 1. So again, I'm going to take that and plug it into f. So f used to be 2x plus 5, where x was my input. But now I want to input x squared plus 1, so I have to take that x squared plus 1 and substitute it for x, which is what I've done here. So 2 times the quantity x squared plus 1 plus 5. So distribute the 2, you get 2x squared plus 2 plus 5 was on the outside. Combine like terms to get this. Okay, this one over here, it says you take 2 and plug it into f. So I started with that because that needed a change. So f was 2x plus 5, but now I'm plugging in 2. So it's 2 times 2 plus 5, which is 9. So now I'm going to take whatever f of 2 was, which is 9, and I'm going to plug it into g. Okay, so g is x squared plus 1, so now it's 9 squared plus 1, which is 82, and that's how I got my answers. So that's function composition. It's essentially when you plug in functions for one another. It could happen just, g of f of x. It could be g of f of h of q of x. It can happen multiple times, but that's how you would do it each time, is work inside out. If you have any questions, please let me know at some point. Talk to your friends and write a summary of what you think this is all about and the key points that you want to remember. Have a great rest of your night.